Now children, you have seen mixture, you have seen compounds, we have seen elements, and so compounds cannot be separated into its components easily, whereas we can separate the components of a mixture, or we can refine a mixture. So the separation of different components, or you can say the impurities of a mixture, is called as purification. So simply now we'll see the separation of components of a mixture or purification of a mixture, meaning is same. So there are several methods, there are several physical methods. Actually, you have to know that the components of a mixture can be easily separated by physical methods. It requires very simple methods, easy methods. And first method is by use of separating funnel. So separating funnel, as the name indicates, is a special type of funnel. It is made up of glass, and so you have to know that this is used to separate the components which are immiscible. It means they form separate layers which are immiscible. So you have to keep in mind that separating funnel is used for the liquid mixture which is immiscible. Now we'll see the structure of separating funnel, how we can use it. See how. So separating funnel, as the name indicates, it is made up of glass, and it has very simple structure like this. Just it is having like this. There is the stopcock, on and off knob, and here we pour the mixture. Mixture is poured. Which type of mixture? The mixture which is immiscible. Mixture forms separate layer. Now this is placed on a stand. Stand is there. So here there is the stand. This is the stand. A stand is made up of iron or wood, depending on that, or plastic, depending on the availability. And here we have the again there is the sliding system. So system for sliding. It can be taken up and down. Again there is a knob here. So it is there. Now suppose if we take mixture of water and kerosene, or you can take water and any oil. So what to do? Over here mixture. So what will happen? It will form separate layers. Separate layers will form. So two layers are formed. Oils are heavy. Oils are heavy then. Oils and water, they have different in densities. So oils are not heavy, and oils, they float on the surface of water in most of the cases. Here I have taken kerosene. So here there will be the kerosene layer, and here there will be water layer. And then we put here beaker or any vessel for the collection, then switch on, we rotate the knob, what happens? Then the liquid starts falling. So first step, water flows down. Water flows down in the first step, and we'll have a close watch on the knob. As soon as here oil comes, then we switch off. Then we remove it. In the second step, kerosene flows down. Kerosene flows down. So this is there how we separate. The second method is distillation. So distillation is used for separating the components which are miscible. So it is also used for separating liquids. So it is used to separate the liquid mixture which are having soluble components. Components are soluble. Components are soluble. So what to do? First, the liquid mixture, it is boiled. So on boiling, what will happen? It will convert into vapors. So here we get the vapors of one component. Then cooling of vapors. Then pure component is obtained. So first we'll have the vapors of component having lower boiling point, because when we start heating, first the temperature reaches, and so first the liquid having lower boiling point will be converted into vapors, and then after that, this is the first point, and second, the component having high boiling point, and so in this manner, so then let this be component A, then component B, because the temperature rises, and so we can have this separation. Distillation is of several types. But here we'll know only the two types. First is simple distillation, and second is fractional distillation. Simple distillation and fractional distillation. Simple distillation and fractional distillation. We'll see how they differ from each other. Actually, simple distillation is used for the components of a liquid. Having the difference in boiling point is very high. So it is used for separation of liquid components having boiling points far away from each other. It is approximately more than 25 degrees Celsius. It is simple distillation. So what about? So it is used for separating the components components having boiling points close to each other. Boiling points close to each other, and it is around 10 degrees Celsius. Around 10 degrees Celsius. If one has 200, if component A has 200 degrees, other component B has, let it be 215 degrees Celsius. So it is around here. If one has 200 degrees Celsius A, so B has 250 degrees Celsius. So such cases, now we will see in detail about this. So distillation involves some basic components. So the components required, or apparatus required, first is distillation flask. Then second is outlet tube for coming out of the vapors. Then condenser, and fourth is collecting vessel. These are four. Then of course we need burner. Burner is of course required. Then we require tripod stand. So these are some of the very important components. So as name indicates, there is the distillation flask. So distillation flask is actually a round bottom flask, or you can take any vessel. So here there is a round bottom flask, and here we'll put a thermometer. A thermometer is put in thermometer to note down the temperature. And here we have the out tube. It is made up of glass here, and it is like this. And here we have this type of arrangement. Now here we mark here the cork. This is the cork. This is the cork. Cork is there. This is what? This is thermometer. Here it is placed. It is not placed in air. No, it is kept on stand. This is your tripod stand. Tripod. Tri means three. Pod means leg. Like this. Here, this is wire gauze. There is wire gauze. Here we have the mixer. This is the mixer. Mixer of two components. Mixture of two components, let A and B. Mixture of two components, A and B. Now here on this, this is the glass tube. This is the out tube. It is bent twice at right angles, and in this there is condenser. There is the condenser. Condenser, it is glass apparatus, and here are the water is passed, cold water is passed, and wastewater comes in. So here cold water is passed from the lower side. Here I have kept it horizontal, but it can be slanting as well. So cold water, and here waste water comes, and there is a proper channel. So there is no pipeline. So just I have drawn here. So, and here there is the keeping in a. This is the collecting vessel. This is the collecting vessel, and of course it is placed on a platform, etc. Let this be the platform, and so like this. So what happens when we heat the liquid? Liquid is converted into vapors. On heating, the liquid is converted into vapors, and so what happens? As A has boiling point like 200 degrees Celsius, B has boiling point 200 15 degrees Celsius, for example, and so first temperature will be gained up to 200 degrees Celsius, then only component A vapors will start moving, and here as we are passing cold water, so there will be the cooling. And due to cooling, what happens? There will be condensation. You have seen in first chapter. So water vapors will be cooled, and so then of course wastewater comes here. So first A will be collected here. So first A will be collected, and so when entire A goes away, then B will be collected. So when A is collected, then we note of the temperature. When the temperature start moving, above 200, then we stop heating, and so this is the simple distillation. Now children, I will show you the real point how we see the different apparatus. See how children see, just for your recall of memory or something like that. This is conical flask. This is conical flask here. This is the conical flask. This is the distillation flask. This is round bottom flask. Flask is of different types. Round bottom flask. This is distillation flask. So it is there. So here cork is there. Here this is the cork. Cork is not having holes, but we make holes, and so here holes are made like this. See, this is there. Here one more hole is there. We put thermometer, and this is the collecting vessel. So like this we collect here in the vessel. Like this we collect, or we can have this. This is one more type of flask. Here we put it like this. This is one point, and here we have this type of arrangement. And now coming this is the thermometer. This is the thermometer. So thermometer is inserted here. This is the point. Now coming to the condenser, very important. So see, it is very huge apparatus. Actually, in reality, it is very huge. It is very huge apparatus. See, this is called as water condenser. This is called as water condenser. Actually, see, just I am going to explain you or show you. This is the lower tube. See, this is the lower tube. From lower side, we always pass the cold water, and so it is made up of two. This is bigger tube, outer tube having more diameter, and see carefully. There is inner layer. There is also very thin. So from this cold water is passed, and here we take out the hot water. And so there are different apparatus for we can have the temperature measurement also. We can measure temperature, and so this is expression how we can have the this simple distillation. Except in fraction distillation there is slightly change. Fraction distillation there is slightly change. See how. Now children, this I have drawn for you about the some diagrammatic representation about the fractional distillation. So this again just I have minimized the size because time space is limited. So again here this is the cold water. This is the wastewater, or you can say hot water. This is water condenser. Condenser the vapors. This is very important point. This is a special type of instrument, and this is called as fractionating column. Fractionating column. Fractionating column. It is just like it is, suppose I show this is something like that. So it is filled with a small bits of the glass balls are there, and so what happens here? Thermometer is here. This is the thermometer. So it is so sensitive. Actually, the different components A, B, they have very close boiling point. So what happens? For the vapors of all the components, they rise together. all the components they will rise together here. But as you know, here the glass beads are there, so here the temperature is not much high. So only one component, the component having lower boiling point will raise upward and it will be converted into vapors, while B will fall down and it will be indicated by the temperature. So this is the basic point. So fractional distillation is used to separate the components having the liquid boiling points very close to each other, around 10 degrees Celsius. So this is about. In addition, dear children, there is the steam distillation. So simple fractional. Then there is steam distillation for the compounds which are highly unstable. Then there is distillation under low pressure. So there are different types. So this is all about the distillation. Children, see one more which was left. This is wire gauge. This is wire gauge. It is simple wire mesh. It is wire, but here there is a special type of material. This is called as asbestos. It is placed on the tripod stand. Coming to tripod stand, see this. 3 legs are there. 3 legs, and here it is kept. It is kept in this manner that this side is on top. But why it is so? This asbestos, it is fireproof. Asbestos is fireproof and it radiates the temperature. It controls the temperature. So temperature comes out, or the vessel is heated, very slowly. Suddenly, we cannot have. One more point, see, this can be used. This one more type of flask. Here, one, there is one outlet tube, one outlet tube. So, there are different like this. See, this is the real arrangement. From here, we attach the, this what we call condenser, and so like this. So, there are different conditions for this, and we can have this like this. Like suppose we have this tube, and so we can have different, and so we place here children like this. This is the real scenery. We keep like this. This is simple distillation. This is the flask with side tube. This is conical flask with side tube, and so this is about the different ways to have the distillation and to separate the components of the.